Welcome to this explainer. Okay, picture this. A user reports a slow checkout. Your heart sinks a little, right? Because suddenly, you're staring at a wall of, say, 200 disconnected log lines scattered across 4 different services, and you're just sitting there wondering, where do I even start? Well, today, we're tackling that exact daily nightmare. We're diving into Grafana Tempo, which is basically the ultimate tool for IT support engineers and developers who are just totally exhausted from guessing where things went wrong.
You know that old way of troubleshooting? The endless scrolling, the blind guessing, the sheer panic of trying to piece together a broken puzzle? It's brutal. But then there's the after. Instead of endlessly searching through logs, you could be looking at a Grafana tempo trace, finding the exact failed operation, the exact span, in something like 3 seconds. It's literally a night and day difference for your workflow.
So, to actually escape all that log hunting guesswork, we rely on distributed tracing. If you're not super familiar, distributed tracing is essentially a method to track a single loser request right from the moment it hits your system, logging its entire journey as it bounces through all the different services, databases, and APIs in your infrastructure. It gives us this beautiful request-level context that traditional logging structurally just doesn't have. Instead of asking, hey, what happened in this one isolated service, we can finally ask, how did this specific request behave across my entire system?
And that brings us to the modern observability triad. These 3 pillars really are the foundation of understanding your system. You've got metrics, which tell you what is wrong, like Prometheus showing a massive latency spike. Then you have traces, which show you where it's wrong. That's Tempo pinpointing the exact service that's holding things up. And finally, logs reveal why it's wrong, with Loki giving you the actual error message. The absolute magic of the Grafana stack is how these signals talk to each other. You aren't jumping between completely different apps, they're all tied together by built-in correlation mechanisms like trace IDs and exemplars.
Now you might be wondering, how exactly do we navigate from a chaotic scrolling log file directly into a nicely structured trace waterfall? Because look, having the data is great, but easily moving through it during a massive high-pressure incident, that's a whole different ballgame. The real secret sauce here is how seamlessly these tools let you pivot to save precious time.
Check out how smooth this actual workflow is. Step 1, you spot that error spike in your Prometheus metrics or Loki logs. Step 2, you just click the trace ID. It's a derived field right there, natively attached to your logline. That single click is a total game changer. Why? Because Step 3, it instantly pivots you out of those messy logs and directly into the full Tempo Trace waterfall view in Grafana Explorer. No copying, no pasting into another window, and most importantly, no losing your context.
Once you're in that waterfall view, you're basically looking at a visual map of time. It's so cool. Up at the top, the root span shows you the total latency of the entire user request. Right below that are your child spans, which lets you zoom in and spot exactly which nested service or database call is dragging its feet. You've also got span attributes. That's the metadata giving you HTTP status codes, durations, and specific error tags. Ultimately, the whole waterfall visualizes exactly where your precious milliseconds are going across the entire transaction.
Section 1. The Power Tool. Precision Troubleshooting with TraceQL. Let's get into it.
So what happens when you aren't starting from a convenient logline? When you've got a massive system generating literally billions of spans, you need to filter out the noise, and fast. Enter this simple TraceQL query, which is absolutely going to be your best friend. In plain English, it's just telling Tempo to find all traces where the span status equals error and the span duration is greater than 500 milliseconds. It's like having a magnet that pulls the exact needles you care about right out of the haystack.
The reason TraceQL can execute a query like that so incredibly fast across massive datasets comes down to intrinsic fields. These are the fundamental properties built into every single span, things like status, duration, and name. And because Grafana Tempo uses a really smart index-free architecture that runs directly on object storage, querying these built-in intrinsic fields is phenomenally fast. Plus, it's drastically more cost-effective compared to older tracing tools that force you to use heavy, expensive indexing databases.
All right, theory is great, but let's actually put this into practice with a real-world scenario. You can actually follow along with something like this in the Grafana Play sandbox using the Tempo demo data source. Here's the setup. A user reports a payment timeout right in the middle of checking out. Revenue is literally on the line. Your heart rate is spiking. Where on earth is the bottleneck? Let's use what we just learned to track this down. We jump straight into Grafana Explore and fire off a quick TraceQL query. We're looking for traces where the route name is post-checkout and the trace duration is greater than 5 seconds. We know the user was checking out and we know it timed out, so this query instantly cuts through millions of fast, successful requests and immediately isolates the exact failed transaction that user was complaining about.
Opening up that trace, we look at the timeline. At 0 seconds, the route checkout span kicks off. At 200 milliseconds, the payment API gets called. All looks normal. But then, look at this, 8.2 seconds. The trace visually proves that the checkout didn't fail because of the database, or even the user's internet connection. It failed because a downstream gRPC call to an internal billing service just hung there for a massive 8 seconds before timing out. Boom, bottleneck found.
But we aren't quite done yet, are we? We know where it broke, but now we need to know why. So we click the Trace to Logs button directly on that failing 8-second span. Tempo instantly pivots us right into Loki, already pre-filtered to the exact millisecond that specific service failed. And there it is, the smoking gun in the logs, an invalid API key error. This is huge because we can now bypass the payment team entirely. They didn't do anything wrong here, and escalate this straight to DevOps to fix that API key.
3 seconds. That's really all it took. What used to take hours of blind guessing, setting up stressful war rooms, and desperately searching through disconnected log files now takes about 3 seconds to find the exact root cause. It's just incredible.
And honestly, this is exactly why I love exploring this topic. The strategic value here is just undeniable. We want to resolve incidents based on hard evidence, rather than relying on log searching guesswork. We're talking about empowering IT support engineers to isolate incredibly complex issues in distributed architectures, and doing it without needing to read a single line of application code.
So, I'll leave you with this final thought. Are you ready to finally stop guessing, ditch the endless log scrolling, and start actually tracing your way to instant answers? Next time that P1 alert fires, you now know exactly how to use the observability triad and Grafana Tempo to trace the lines straight to the solution. Get out there, set up some traces, and take back control of your systems.